against the wall effect.
In fact, this is the problem we also face. I don't enjoy teaching at all on Zoom because there is no eye contact.
Here in the Netherlands, if someone is not showing the face in real life, immediately it's excluded from the course. So actually, the host is immediately switches him or her out. So this is how it is done. I tell you frankly, we know each other for rather long. It's sometimes annoying because when you go into a difficult explanation, you would like to see on the eyes if it is understood or not. And several times I feel that I do not have feedback.
True. Very true.
But whatever. Next time, 5 minutes, as I always say. Good. Time is here, so we have 2 minutes. Did you initiate the recording?
Yeah, I have initiated recording also, and I had made it live on the YouTube also.
Okay, good. So then I believe the best for me is to start sharing the screen and then waiting for your words when to start the talking.
Okay.
Excellent.
So, Imre, I'm starting the recording once again.
Okay.
And maybe in a few seconds, you can start your lecture.
Yes.
Although only 2 participants have joined until now.
No problem. I have to do the job.
So you can start now. It's true, you can start. Thank you.
Thank you. Good morning to everyone, or good afternoon, or good evening, depending on where you are in the world. So let's go to the next lecture of the Designing Cyber-Physical Systems for General, Social, and Personal Utilization course. Today's lecture will be about the types of computational learning with applications in cyber-physical systems. So the second part of the title indicates that not all types of computational learning approaches will be considered, just those which do have some significance from the point of view of applying them in cyber-physical systems. The first block will be about types of computational learning strategies and mechanisms. Please recall where we are at this very moment. Last week, I told you that there is no smartness without awareness. Yesterday morning, I told you that there is no smartness without reasoning. Today, I am saying that there is no smartness without learning, which means that we discuss today the computational learning as an integral part of operation of cyber-physical systems. So we have to go back to the so-called computational smartness cycle, and starting out from the smartness spiral, we can place the learning activities on this spiral after building awareness and productive reasoning. And we can say that actually the strategic learning, what is on system level and not on component level, includes constituents, for instance, as stratagems of learning, machine learning algorithms, deep learning algorithms, and semantic interpreters. These will be discussed in my follow-up presentation. For the sake of simplicity, here is a definition of computational learning, and the term refers to the development of mathematical frameworks as well as computing mechanisms for predefined learning tasks and application. So important is here the predefined nature, that we are addressing tasks which more or less define or at least circumscribe. When we are talking about learning by cyber-physical systems, one of the most important enablers is the computer and software science, which produces a lot of theories, methodologies, and frameworks for the work. But also, computational learning is a large-scale enabler, which includes machine learning, and a subset of it, which is called deep learning. In addition, enabler of learning by cyber-physical system is the data and knowledge mining. You have heard about this topic earlier. And also the concept and implementation strategies of cyber-physical systems, which are actually tailored towards learning and which raises the need for learning. And then I mentioned that more and more cybernetics is influencing the implementation of cyber-physical systems and reason. Let's talk about computational learning. Computational learning in the view of those underpinning or explanatory theories which try to capture its essence and try to put it into a kind of practical context. The first underpinning theory is called computational learning theory, often abbreviated as CORE. This is a formal mathematical study of learning tasks. Obviously, when we are talking about learning, the very first question is what to learn. What is what we need to learn? And then, because every problem is different, and there are problems out there with different complexity, the computational learning theory, first of all, study the difficulty of the problems and what they imply for the computational learning. And then it also focuses on the use of formal methods in learning systems. As the literature reflects it, CORE is mainly focusing on supervised learning tasks. A complementing theory of computational learning theory is the statistical learning theory. It has a different focus. While computational learning theory focused on the learning task, statistical learning theory is focusing on the behavior of learning mechanisms and algorithms in general. So if you try to address a particular problem with a particular type of learning mechanism, how it behaves, how efficient it is, how much overheads that have for the preparation for the application, and so on. So this is a kind of statistical learning theory implies a kind of formal analysis of the real problems and the real algorithms, which are obviously complex. For this reason, their study is challenging. And due to this challenging nature, the current application of these two theories is limited to interpretation or challenging real problems and algorithms. The complexity is typically reduced to binary classification tasks, so mainly binary classification tasks are studied by them, and simple binary rule-based systems. That's where they most frequently apply. And it means that unique and specific application-related learning mechanisms are at this very moment not studied by any one of these computational learning theories. The theory of learning problems has a more specific approach as well, which is often called the probably approximately correct learning, the POC-L approach, which is based on the theoretical machine learning framework developed by Valia. The POC-L can be considered as a premier subfield of computational learning theory. So it is focusing on not the exact solution, but exact solution of application problems, but it is more interested in the approximately correct solution, the tentative solutions, which are not really pre-coded. So the POC-L theory seeks to quantify the difficulty of the learning task addressed by system-level learning. So it looks for system-level solutions. Let me give you an example. For instance, in supervised learning, no matter, it doesn't matter if you don't know it yet, later on I will talk about it. So in supervised learning, an unknown underlying function is typically sought for, which is facilitating the mapping of the input data to the output data. This function is producing for us a kind of approximation, so not a exact mapping. It is not known how this mapping function looks like, but we suspect that there is a mapping function existing in the overwhelming majority of practical application. And we also assume that examples of data produced by the function are given. So this leads us to a kind of feedback type of use and the generation of this function. The POC-L is concerned with how much computational effort is required to find a hypothesis, a fitting model, or a transfer function that is a close match for the unknown target function. Let's talk about the basics of machine learning. Everybody knows that learning is the acquisition of knowledge or skills through study, experience, or being taught. Computational learning is a dedicated effort to implement the potential of learning on computational architecture. It is not obvious that computational architectures are able to learn according to the human model, the human interpretation. Machine learning is one of the most exciting technologies for the reason that one would have ever come across. Machine learning is very broadly and actively used today, sometimes even misused or overused, and the literature is very rich, very difficult to navigate in that, and very difficult also in the practice to find those sort of tools which are really useful and needed. Machine learning equips cyber-physical systems with the capability of learning without being explicitly programmed. So while the traditional learning techniques like symbolic learning and production rule-based learning needs a kind of pre-program in terms of the rules which are available. In case of machine learning, the system developers are relieved from this particular task because machine learning, especially the neural network-based machine learning technologies, can work without being pre-programmed. There are several standard mechanisms that are dedicated to a small set of applications and tasks. The machine learning pipeline is the next thing what I would like to talk about. This is actually a generalization which applies to all kind of machine learning strategies and mechanisms. So the general and this particular machine learning pipeline assumes that the general process of machine learning is a kind of never-ending life cycle in which its capabilities and technical properties are iteratively changed as new annotated data are utilized. So what it means in the practice is that we start out from defining a task and we collect data related to this particular task, and then we go into the first loop within this pipeline or cycle, which means that we have to explore a possible model. We have to select or create a model. And then we have to test and evaluate this model, and then we can go further with in our work with the model, and we can refine this model. The refined model can be further used to integrate and deploy and monitor and maintain functions. So this machine learning pipeline with this looping describes actually the essence of every machine learning algorithm. So the next thing is the aspect of computational learning. Here I have to stop for a moment and explain something what I have heard already from the students. For the students who, in the context of intellectualization of cyber-physical systems, we hold lectures on the different machine learning approaches. They told us that it is not a discipline, but a jungle. There are so many things there to know, to learn, to acquire, and sometimes it is difficult for those who are not professionals in the field but want to deepen. That was the motivation behind why we have developed a kind of interpretative model of computational learning with a focus on machine learning. And it identified three major aspects from which we have to look at machine learning. Obviously, these three aspects are interrelated, as I try to symbolize here within the triangle. The four aspects are the learning strategy. So we believe that without being able to separate the learning strategies and knowing the learning strategies, you will not be able to learn the rest of machine learning. In addition to the learning strategies, we have so-called learning mechanism. The term mechanism was defined and explained to you already. Obviously, here we are talking about those computational mechanisms which are dedicated to learning. So these are the two contrasting aspects of machine learning. And there is a third one, namely the learning problems. What sort of problems can I or should I address with machine learning? And obviously, in order to be able to make a decision with regards to the addressable problems, you have to be aware of the learning strategies and the learning mechanisms which are actually based on the strategies and operationalized to our particular problem. So this is that general reasoning model what comes back. In the first lecture, I will address the learning strategies and learning mechanisms. In the second part today, in the second lecture, we will talk about the so-called canonical problems of machine learning and hope this way this jungle will be walkable and you will see the essence behind the trees here. let's talk about the articulation of computational learning. The model, what we can use here is what we just introduced, or what I just introduced. On the fields of learning strategies, we can identify supervised learning, semi-supervised learning, unsupervised learning, reinforcement learning, deep learning, convolutional learning, physics-based, physics-informed learning, extreme learning, and bagging learning. Obviously, I should say that there are even a longer list behind, which are not mentioned here than mentioned, but we believe that these are the most significant ones, what in the first attempt, students who are trying to be developers of cyber-physical systems should be aware of. Then, on the side of learning mechanisms, actually, we may list again a long list of mechanisms, learning mechanisms, starting from relatively simple ones and ending up with rather complex ones. So linear regression, logistic regression, naive-based approach, k-nearest neighbors approach, support vector machines, diffusion trees, random forest, common neural networks, deep neural networks, as samples are learning mechanisms, but we have to be aware. And then the third aspect, the learning problems here, for instance, object identification, cluster specification, object classification, pattern recognition, functional regression, behavioral generation, and knowledge acquisition can be mentioned. There are many more, but I believe that these are those which can be called as canonical problems of machine learning and will be interpreted that way. So what I would like to see that there is a wide repertoire of the strategies of the mechanisms and also the application problem. And it is not true what the literature suggests that the latest is the best and forget about everything. I am objecting it. It is simply not true. So let's start with the common types of learning strategies, and most probably before a short interruption for questions, we can discuss some related things. So I mentioned that one of the prominent strategies is supervised learning. What the essence of it is that it approximates a target function that maps inputs to outputs. Outputs are known and provided, inputs are known and provided, and the relationship between them is actually the task to figure out for this learning strategy. The second one is semi-supervised learning. It is a particular combination of clustering and classification algorithms to group data together based on similarities and use for labeling. I will explain the essence of this later on. Unsupervised learning doesn't need actual corrective feedback as it is practiced in the case of supervised learning strategy. Unsupervised learning learns patterns from untagged data by discovering hidden patterns, relationships, or possible data grouping. Then the next one is reinforcement learning strategy. It tries to include information from the learning environment in the process of learning, and its essence is finding a balance between the exploration, the undisclosed territory of learning, and the exploitation, the actually what the current knowledge is. Then comes deep learning, which is one of the most popular study fields nowadays. Deep learning is typically uses neural network architectures which has extreme large number of layers with different functionality to simulate the behavior of the human brain, obviously with all the limitations which are out there. Then the next one is convolutional learning, which is somewhat limited in terms of their application of opportunities, but on the other hand, in the relevant fields, it is a very powerful approach, which is trying automatically learn a large number of filters in parallel specific to the training data set under constraints. It uses multiple layers with completely different functionalities in order to process the information, consolidate the information, and select those approaches which really lead to a kind of reliable classification in the end. Later on, you will hear how it is used, for instance, in the field of image processing, image recognition, and actually what type of method functions are used in order to make the process operational. Then the next category of the learning strategies is the so-called extreme learning. And extreme learning strategies try to use the concept of random projection and early perception models to do specific kind of problem solving. We will briefly discuss this later on. Attribute bagging is a term for operationalization ensemble learning in machine learning, and actually every node is if it is a neural network based implementation, then every node is informed multiple times about multiple pieces of information, and this way the machine learning model is able to do a kind of bias variance checking and achieve a trade-off and produce a model which has a reduced variance. Then a popular strategy, in particular for those who are focusing on machine learning related to physically intensive cyber-physical systems, for instance, in the robotics, transportation, or mobility industry. Physically based learning strategy uses differential equations and various numerical procedures to influence the learning by neural network. So the basis is neural network, and then when the assessment of particular nodes is happening, then information is injected based on the evaluation of differential equations or as a result of different numerical procedure. So this is how the learning in the virtual world is connected to the activities in the physical world. So I believe here the time has come to stop for a moment and to stop sharing and to face the question if you have any comments, if you have any question related to what we have discussed until now, please.
Any question from anyone?
No, sir, no questions.
So there is no question, Emily. I think you can continue.
Thank you so much. Hope everything was clear nevertheless, and you could see the structure as I tried to build up, and it explained itself. Okay, let's go further and let's see the second part of the presentation. I share the screen again and then I go further with my presentation, more specifically with the overview of supervised learning. Obviously, there are many, many books and papers published on this particular topic. I cannot go into a detailed exploration. I just would like to summarize the most important things what students who are dealing with cyber physical system development should be provided. So first of all, let's start with a categorization of supervised learning, because supervised learning naturally divides into two types of approaches. One is called the lazy learning supervised approaches, and the second one is the eager learning supervised approach. In the lazy learning domain, when the convergence is not really guaranteed, we can mention the k-nearest neighbor, the locally weighted regression, and the case-based learning strategy. You have heard about this earlier. In the eager learning category, we can mention practically all implementation of the artificial neural network, the Bayesian network-based learning, decision tree-based introduction, Gaussian inferring processes, radial basis function, support vector machines, and linear, multi, and polynomial regression. Later on, I will address this issue. Here you can see these capital levels. So actually, I would have liked to give a kind of preliminary indication of what the specific approaches of supervised learning can be used. Here is the region to understand what I am talking about. Where you see K, that typical method is useful for classification, but also for approximation. Where you see C, for instance, here at many places, that is typical for clustering. The difference between clustering and classification will be explained to you later. No problem if you immediately cannot separate these two things. Then let's have a look into the classification of not supervised learning technology. Like supervised learning approaches, the not supervised learning approaches also divides into two categories, the unsupervised learning and the stimulated learning category. In the unsupervised learning category, we can name something like several items like nearest neighbor approach, furthest neighbor approach, k-means approach, artificial neural networks also in a particular setup, mean shift of approach, density-based evaluation, dimension reduction. On the other side, with regards to stimulated learning, we can talk about value iteration learning, Q learning, temporal difference learning, PDL, gradient-based learning, artificial neural network prepare a subset of them prepared for stimulating learning. Then we can also identify game-based learning approaches and reinforcement learning approaches. Here again, the legend applies. So wherever you see a capital A, it means that it is something which is good for approximation, a kind of regression. Those which are indicated with capital C are typical for clustering, and K would be, but here it is not relevant for definitive classification. So after this overview of the landscape, let's talk about some important issues of using machine learning inside the physical system. The very first thing is that because machine learning needs training. Without proper training, there is no model what we could apply for problem solving in particular context. So several times the question is raised in the literature, but also I heard it from students and colleagues that why do learning mechanisms have to learn every dumb thing from data only? So actually, why we don't have higher level learning mechanisms which are benefiting not only from the hidden or internal relationship between the data, but also utilize knowledge, explicit external knowledge. You remember that I already had a brief introduction to the topic of abductive learning, and I explained that besides the procedural aspect, abductive learning also a knowledge intensive type of computational learning, and it uses various bodies of knowledge in order to make the decision making process more robust and the decision more acceptable. So this is a relevant question related to machine learning mechanisms, but let's elaborate a little bit more on it. It is desirable to be able to inject domain knowledge into machine learning models. But if you consider the currently available and especially the so-called standard uh, machine learning approaches and the models what they are generating, these are actually black boxes. We don't know what happens inside, and for this reason, it is very difficult to inject knowledge in order to make the models more rich, more specific to the application, or even easier to process. So if we consider the literature, we can see that these issues, which I just mentioned, are not included even in the latest and greatest deep learning-based language models and approaches. So there is something here for research and also for developers. Because it is obvious to say if we really going to replace human decision makers by machines, we need a kind of reflective thinking algorithm or many this type of algorithm, which are not only looking at the problem up front, but also in the multiple cycles and their work, they reflect on what was achieved and improve their results accordingly. I don't want to repeat, but I have to re-emphasize again the importance of interpretability in the context of learning mechanisms and the decision-making processes which are tightly connected. This is practically an open issue. So what we can conclude that research is still needed on complementing deep learning methods, and we have to be careful with the current enthusiasm towards the newcomers from the research lab, because the machine learning algorithms are supposed to be reduced in terms of number in the future. I mean, less and less new machine learning algorithms will be proposed, because it can be already seen that the majority of the learning algorithms, what we have, and the machine learning mechanisms, what we have, is actually refinement of some previous concepts. So I don't believe that there will be a radical change in the domain of traditional machine learning in the coming year. And then let's take the different strategies and let's see what they involve. Supervised learning incorporates external teaching, so each output unit is told what its desired response to input ought to be. So commonly used implementations of supervised learning, these are the mechanisms like error correction learning or reinforcement learning or stochastic learning. An important issue in case of supervised learning, which operates on the deviation of the learned model from the expected output, is the error convergence. Somehow, a sophisticated learning mechanism should deal with the issue of error convergence. And this is exactly what I just mentioned, that to reduce the error between the desired and the computed unit value. In many cases, weights are used to minimize the errors, for instance, in neural network. And actually, the setting of the weights is a kind of vague guarantee that there will be a convergence, and at a given moment in time, there will be a acceptable or below the threshold error found. So the method in which the sort of setting of the weight is happening is called the least mean square LMS convergence method. I have to mention that supervised learning is typically prepared offline. It means that the whole procedure decomposes into two stages. One is the training stage, when actually the model is, the learned model is developed, and the other one is the application phase, when the model is applied to new data and the model is used with the aim to generate new results. Obviously, a neural network can learn online if it learns and operates at the same time. There are efforts to equip neural networks with the capabilities to improve themselves while they are beyond the training period, when they are actually operating. So when we are talking about the offline training, we have to see that the human play an important role in this. Namely, we start out from a stream of raw data which are unlabeled. The labeling is actually a kind of semantic tagging which assign meaning to a particular individual raw data or a subset of raw data. And then in the end, we would like to have data with predicted labels usable for training. This is what actually the beginning and the end of the annotation loop means. And this is where the humans have to be involved, because in principle, there is an opportunity for automatic labeling or automated labeling. When the raw data are labeled, and then we can have a prepared set of data which is characterized by the label. In this case, we are deploying machine learning to predict the most likely label. Obviously, here the machine learning cannot be more than clustering. Then, if it is not possible to do the labeling with computer-based mechanism or algorithm, then we have to go into a kind of active learning to select those sort of data which are important to be labeled, because the stream of raw data typically contains a huge amount of items. It might be that some of them don't play any role in the procedure. So this is where we have to select by active learning which items of the data stream deserves attention from the point of view of label. When this subset is generated, there comes the human experts with the label. So they are annotating to this subset of selected data. They are allocating annotations and they label the particular data. When it happens, when the labeled data are becoming usable for training, obviously it has to be considered that transfer learning can also be used here, which means that the labeled data might be combined with labeled data which were used in similar other applications. This is the essence of the transfer learning, to take over already labeled data from other places, also useful models. And then with these, the training of the machine learning mechanism can happen, and this way it can the deployed the developed model deployed in the procedure, in the follow-up action, as it would have been produced by the computational mechanism. So this complexity is something what we have to consider whenever we are talking about annotation of data. Semi-supervised learning is a machine learning approach which is a combination of supervised and unsupervised learning. Semi-supervised learning is used in analysis where a large quantity of unlabeled data is available alongside with a few data points that have been labeled. So in the case of semi-supervised learning, both labeled and unlabeled data are considered. Don't forget that in case of supervised learning, fully labeled data sets were assumed. Semi-supervised learning focuses on learning from each of the small number of annotated samples. So the starting point is the annotation, and obviously it can be, for instance, applied to image processing, and the basis can be image. The starting labeled data sets are used for sorting, tentative sorting of the non-labeled data sets, and in this case, in this way, to allocate all the data which are available in clusters. Semi-supervised learning is useful in applications where labeling data is limited or expensive, for instance, in drug trials, complex experiments. A common example of application of semi-supervised learning is, for instance, a text document classifier. Sometimes there is a need for using this in cyber-physical systems. The realization of semi-supervised learning is based on methods such as probabilistic models, graph-based semi-supervised learning approaches, transductive support vector machines. Just continue with semi-supervised learning. I would like to mention that semi-supervised learning manages to train the model with less label training data than supervised learning is by using pseudo labeling. Semi-supervised learning can combine many neural network models and training methods using the following steps. First, training the model with the small amount of label training data just happens as in the case of supervised learning until it gives good results. When the good results are available, then we use it with the unlabeled training data set to predict the output, which are pseudo labels since they may not be quite accurate. Then linking the labels from the label training dataset with the pseudo labels created in the previous step is happening. Afterwards, linking of the data inputs in the label training datasets with the inputs in the unlabeled data is happening. And finally, training the model the same way as it did the label set in the beginning to decrease the error and improve the model accuracy is the closing step. Since time is running, let's try to shift our attention to unsupervised learning. The major characteristic of unsupervised learning is that it uses no external training and it is based exclusively on local information, which is in the data and in the problem. The goal of unsupervised learning is to extract patterns from the input data without reference to labeled outcomes, because actually there is no labeled outcome provided. So by a program self-organization, unsupervised learning mechanisms manage the data presented to the network and detect their emergent collective properties. The main approaches to realize unsupervised learning are, for instance, the Hebbian learning mechanism and the competitive learning mechanism. Another aspect of learning concerns the distinction of the training of the network and the subsequent operation phase. As I mentioned, it is two partially separated in the semi-supervised learning and fully separated activities in case of the supervised learning. If you use neural networks for unsupervised learning, then this can learn online, and the learning time and the operating time can be connected by specific mechanisms which extract information about the correctness of the actual states of the learning processes. Unsupervised learning is performed online. So here there is no need for the contribution of the knowledge engine. The next topic, what is important for us to know about, is reinforcement learning. It refers to goal-oriented mechanisms which learn how to attain a complex objective, which are aware of the goals, which maximize along a particular dimension over many steps, And the reinforcement learning mechanism address tasks where a computing agent needs to learn to interact with its environment, receiving inputs, making sequential decisions to maximize future reward. Reinforcement in this context means that the agent learns from a series of rewards or punishments. So if the learning process goes towards some obvious result, in that case, rewards are applied. Why? If it deviates from the expectations, then then punishment is applied. Reinforcement learning solves the problem of correlating immediate actions with the delayed returns they produce. Typical reinforcement learning methods are cue learning, direct policy methods, and the probabilistic inference for learning control, which is often abbreviated as the PIRCO method. Applications for reinforcement learning are typical in robotics, in the games, and the games are extensively used for cognitive purposes inside the physical system, but also in training and in dialogue systems. Before stopping with this block, I would like to briefly go through 7 major challenges of machine learning. The first one is analyzing huge amount of data. Typically, poor quality, unclean and noisy data are used for building or training models. The data pre-processing, therefore, should remove outliers, filter missing values, and remove unwanted features. It's obvious, but every time it has an overhead because time and expertise is needed. And then the third thing is related to the analyzing huge amount of data is avoiding making inaccurate or faulty predictions. The second major challenge is the underfitting of training data. Underfitting is actually means, in simple words, then we have a weak model to reason. But the expectation is that the data should establish an accurate relationship between the input and the output variables. And sometimes the data may be too simple or just very limited in terms of numbers to establish a precise relationship. But luckily, there are opportunities to overcome these. Let me mention a couple of them. For instance, maximize the training time, enhance the complexity of the model, add more features to the data, and reduce regular parameters. Increase the training time of the model. Then let's move to the third major challenge, which is the opposite, the overfitting of training data with training data. In this case, the model is actually less sensitive to the individual deviations, and therefore it is not able to identify small deviations. So it happens if the model is trained with a massive amount of data, and obviously this can negatively influence the performance. Overfitting might be also mean that training with noisy or biased data may have negative effect on the overall performance. So both large amount of data and both noisy and biased data should be avoided as much as it is possible, obviously, in the training field. And imbalance in subject related to the training data is also something what is to be avoided. Lastly, a vast amount of biased data is a source of mystery. So if the training data is dominated by undisclosed bias data, it has a negative effect. This issue can be tackled by analyzing the data with utmost level of perfection, but obviously if you want to analyze the data, you need dedicated methods, experts, and time. Use data augmentation technique. This tries to automate the process, but it is still in a rather premature stage, according to my best knowledge. And a simple approach is remove outliers in the training set. And ultimately, we may also think of selecting a model with much less data features. Then the next challenge of machine learning that it is an error-prone complex procedure. Typical error sources are magnitude of the data, distribution biases, data construct, mathematical calculations, and so on and so on. So we have to be aware of the sensitivity of the output data to the deviations in the input data. The next one is the lack of training data. Here, the major issue is that sometimes we try to spare time, or sometimes we are limited by accessing consolidated sense of data, and at the same time we have a complex problem at the hand. And this complexity influences the learning opportunities when we are in shortage of training data. And interesting issue here to consider that weakly trained local features may surpassed by global features. This is why I mentioned that it is sometimes observable that the network, when it is overfitted, is not able to identify local features because they are suppressed by global ones. And the last issue here is the insufficiency of the discriminating feature is influential, and it is also a quality matter. Then the next issue is the slow implementation. Huge amount of time is needed to get correct results, and time is increased by slow algorithms, data overload, and excessive experiments. The developers need constantly monitor and maintain the data sets, the training procedure, and the models in order to have the best possible output. And then the last one is the potential imperfections in the algorithms, because not only just the data, but also the mechanisms and the algorithms can be erroneous. So we have to consider that the model may become useless as the data grows in the future, because algorithms will not be able to select the needed data and process them properly. And adaptation of the algorithm needs a software engineering knowledge, obviously, and the algorithms needs to be continuously updated, which needs on the other hand, a permanent maintenance. So at the end of this block, I would like to kindly call your attention to a couple of seminar publications. For instance, the first one under the title Elements of Computational Learning Theory. It is very good for you to learn about what are the underpinning ideas of computational learning. Then IPADIN published a very nice book recently on machine learning. This is a rather comprehensive study. I would like to suggest you. There is a paper on physics-informed machine learning. I gave here the bibliographical details of that. And there is a nice paper on distributed machine learning. In fact, a survey from colleagues and Mahesh paper on machine learning algorithm is something what we can learn a lot from, and Ray's paper on a quick review of machine learning algorithms are relevant. So this concludes the first lecture today. I hope that I could explain you the fundamental problems of overseeing machine learning, and I hope that I could illustrate you the strategies and the learning mechanism, how they are, what they are, and how they are interrelated. If you have any question or comment, I would be pleased to answer it, because after that we will go into the break if I am right, and then we will continue with the second lecture, which will be about the canonical problems of machine learning. Pune, please, the word is with you.
Yeah. So anyone has any question?
Yes, sir, I have a question.
Yes,
Yeah,
please.
please.
Sir, so my question is, sir, how do we select which machine
Sorry, the line broken on my
Anil, your voice break actually, so please ask again.
or can you please put into the chat,
technique is suitable for my work?
or please
Okay, sir.
repeat it.
The question in the chat box actually.
I cannot see anything in the chat, but I also cannot hear anything. So, now someone who heard it, could you please summarize?
Anil, can you put your question in the chat box? Anil and Solia,
Okay, sir.
just put the question in the chat box because
My chat box is still empty, but I'm waiting for the question. Yeah, I can see it. The question is how to select which machine learning technique is suitable for a particular case. Very relevant question. Actually, this was the main point in the presentation. I cannot tell universal rules. The problem is that there are too many machine learning techniques available. This situation is due to the current hype of artificial intelligence research. What the selection is concerned, because I believe this is the essence of this question. How to select the best is to match the need of the application with the services of the machine learning. I believe I mentioned already a couple of things. For instance, if your machine learning task is described with very limited number of input data, in that case, for sure, you will not be able to use supervised learning techniques, because the few amount of data limits the training opportunities and causes all kind of unconditioned situation. This is, for instance, one thing what you can say. But the The machine learning is not necessarily based on neural networks. It can be, for instance, simple, for instance, regression-based technique. So again, starting out from the application problem, which may be that you want to make a prognosis how the things are going. And then if you have sufficient data for making a regression, and then you see the tendency, you may use this learning technique to provide the information what your cyber physical system needs. So what I say that it is in itself a huge challenge on its own, and and uh, and this is where we need the knowledge about the strategies, what the strategies allows us to do, what the mechanisms can provide, and what is expected by the different applications. So that sort of triangle is a kind of implicit reasoning model for this. That's all what I can summarize now. I know that it is not an exhaustive answer, but please be aware of the fact that most probably no one can exhaustively answer this question because it has so many facets. It's rather multifaceted. I haven't come across with a simple question yet related to machine learning.
Is it clear to you, Anil? Clear?
Yes, sir. Yes, sir. Thank you, sir.
Any other question anybody has? Any other question? Okay, otherwise I'll request all of you to kindly switch on your cameras. We'll just take a record of your presence. Jefferson, Dheeraj, Anil,
Sir, I have some problem with my camera.
no issues. Jefferson, Dheeraj, so all ready?
I see new faces. Welcome. Thank you for visiting the course.
So Professor Prashant Jain has joined today. He asked me
Sir,
to attend this lecture long time back, but probably he was busy other activities. So he joined today, and Imre,
there few more. I have joined few more.
I don't know whether you are aware or not. Professor Jan is presently heading our department actually. He's head of mechanical.
I think Professor Harvath might have remembered when he visited us
Sure. Welcome.
first design workshop.
Nice to see you. Nice to see you, sir. Really.
Okay, then we have a short break of now 8 minutes. We'll reassemble at 3:15 as per our schedule, and we'll request Professor Imre to take another. Meanwhile, I have one announcement for all of you, and with a request for all of you to communicate to your other colleagues also. I'll also ask Harshal to drop a mail to all of you. Friday last lecture, that is from 4:30 to 5:30, you have the GIAN examination, which is a routine matter as per the GIAN guidelines. So it will be like a subjective type of question paper where you will be just asked what you have learned from this particular course. So we'll conduct at 4:30 and you have to submit by 5:30. It will be easy and the routine exercise. Don't get panicked that you have to write the examination. But being a mandatory requirement, you have to do it. And you can either write by hand or you can type whatever you know. The purpose of that is what you have done, because we have tested you. We have done a free course quiz also, so we know where you stand, and we wanted to understand where you stand after 2 weeks of time. Okay, so marks scoring is not important in that particular quiz, but your presence is important. If you are not present, probably will not be able to give you certificates also. So please circulate this word to all, and we'll reassemble at 3:15. The link will be on, but Professor Imre will start his lecture at 3:15 Indian time. Thank you, Professor Harvath.
Thank you. And then let's continue in 5 to 8
In
minutes.
5 minutes now.
Yes, thank you so much.
Yes. Shall we begin? Emre, are you there? Emre, are you there? Yeah. So welcome back, Emre.
Yeah, sorry for I just have to squeeze a couple of joys or orange.
You can
So
start your second.
actually, I'm ready for continuation. I share the screen and then just open the second lecture. Please let me know if I can start. Hello?
Yes, Professor Imre.
Can you hear me, please?
Yeah, it's audible. You're very much audible.
Can I start?
Yeah, please. I've already
Oh,
requested
thank
you.
you. Sorry, I
Please
didn't know.
start. Yeah, please.
Yeah, thank you so much. So in this second lecture, I would like to give you an overview of the canonical problems in machine learning. And in the first block, I will focus on those application cases which are related to identification, clustering, classification, and pattern recognition. And I will explain them, and also I will expose the differences. For instance, what exists between clustering and classification. So you have seen this figure already. What I would like to talk about is the learning problems at this very moment. And then it might be a little contribution to the understanding which is needed, for instance, to answer the questions what we heard at the end of the previous lecture. So these are the major learning problems, and they are called canonical problems of machine learning for the reason because canonical in this context means that conforming to a general rule, this is what they reflect, and acceptable and frequently addressed tasks. So these often happen in the context of cyber-physical system application, and then the cyber-physical, this somewhat cyber-physical system development should consider these learning problems. So the in general, we can say that the canonical problems are addressing one or other way of classifying machine learning problems. Common machine learning mechanisms are orientated to various problem categories, and these are the categories now in full size, what the full size fonts, what we are talking about. These mechanisms support application independent problem solving by CPS. So these are not application specific problems, but these are generic ones which may appear in the same form in the case of multiple system applications. For this reason, you can find a literature even formal treatments of them. They have been formalized considering that there is a vector of object which is characterized by data, obviously, and they form a set. And there is a target set of patterns which are either existent or should be explored. And then there is a behavior which is determined by this particular target set of patterns. And then C is a formal concept, and K is the set of knowledge. And U is an operator of knowledge composition. It's a composition operator. So here is what you can see. For instance, if we whichever to select, for instance, the learning pattern recognition, it means that we have a vector of objects, and we have pattern. And the idea is to have a match, a mapping, a equality mapping between the elements of the vector of object and the pattern. So this way, all of them can be described. I believe it is beyond that point. It's not interesting for us for the further discussions, but you can remember that actually the canonical problems do have symbolic mathematical interpretation and descriptions in the literature. Let's start with the first one, with the so-called object identification problem. Object identification most frequently appears in the field of computer vision. Often it is referred to as a computer vision technique for identifying and recognition of objects in images or in videos, still images or videos. Object identification can be orientated to people, various physical objects, scenes, arrangement of objects and people, and other visual details based on an amalgamated set of characteristics. The goal is to teach the computer to gain a level of insight of what an image contains. Object identification is typically implemented in two subsequent steps. The first one is object detection, to detect if something really located in the image. And this is the object detection, which is defined as the process of finding and locating instances of objects in images. And then object detection allows for multiple objects to be identified and located within the same image. So object detection doesn't restrict it to one single object. It can be even an ensemble of objects together. The second part, or the second step, is object recognition. So when you know that something is in the image, but you don't know yet specifically what it is all about, then you do into do object recognition, and it can be done and typically done by template matching, which uses a small image or template to find matching regions in a larger image. If we are talking about neural network and deep learning based technologies, then we obviously should mention that the features are important elements for object recognition, because the existence of and the position, for instance, of features helps the object recognition process. Object recognition can be done by image segmentation and with blob analysis. Blob is a vague region in which a search or sought for image part may be located or may located, and typically we use for object recognition simple object properties such as size, color, and shape. As I mentioned, other techniques are using feature, but they should be defined and identified. Then the next canonical problem is cluster specification. Clustering in mathematical and computational terms means a automatic division of data and objects into different clusters according to their different characteristics. So cluster specification organizes the data or object by creating clusters so as the members of the clusters are similar. Clusters are not predefined. This is the major difference actually with regards to classification approaches. So clusters emerge. Clusters define in the process of computation, and their number and contents depend purely on the possible separation of the data. So how the data are sorted into categories and clusters. Clustering typically needs an unsupervised machine learning mechanism since the clusters are not known. And if they are not known, in that case, we don't know how many of them exist and what content they have. Clustering mechanism should complete pattern division for unknown data and objects. Generally, clustering works well in the case of high degree of similarity and when the data and objects in different clusters are quite dissimilar. So what it means is that if there is a even distribution of the properties, the features, then it is very difficult to make meaningful clusters. However, if they are significant groupings with regards to the characteristics, in that case, these groupings can be considered as the potential content of the cluster. Since clustering is very important activity with regards to smart cyber-physical systems, I would like to mention that clustering mechanisms may use 5 computational methods, which are the partitioning method, the hierarchical method, the density-based method, the grid-based method, and the model-based method. There are almost interchangeably used, but I believe depending on the input data, we have to consider that what is the best method for this, for clustering. And the clustering process mainly includes the following steps: data and object preparation, feature extraction, characteristic extraction, feature selection, similarity calculation between the different entities, and clustering the data and the object entities accordingly. Finally, when the clustering is completed, we have to see if there is any outlying, so data or objects which are not sorted in clustering or in clusters, or if there is any kind of unwanted overlap between the defined clusters. A very robust and ingenious form of clustering is the so-called k-means clustering. Let me summarize briefly what it is all about. So the k-means algorithm attempts to assign objects to a cluster based on how close they are to the centroid of a cluster. The k-means algorithm starts by randomly selecting k number of objects and adding each to an initial cluster. The value of k has to be provided and represents how many clusters the set of objects will be clustered into. The number of clusters has to be known rather than being discovered during the clustering process. So this is a kind of influence already from the field of classification. After the initial objects are assigned to clusters, the centroid for each cluster is calculated. Then the remaining objects are assigned to the cluster with the closest centroid based on the similarity function. So actually the distance of the entities and the centroid is calculated, and based on the configuration of the entities, a new centroid is computed and defined. Once this initial setup is completed, the algorithm moves to a iterative process and process of recalculating the clusters. During each iterative update, the centroid for each of the clusters is recalculated based on the current members of the group. All the objects are then iterated over and assigned to the cluster with the closest centroid. Then this process is repeated until there is no change in the cluster assignment between two consecutive iterations. And once the iterative process is done, the resulting clusters are the results of the algorithm. When using the non-Euclidean similarity function, it is possible to have a situation where the cluster will never stabilize. So the whole procedure is unsettled and unstable. This could potentially happen when the clusters are oscillating between a set of finite states. Consecutive iteration will thus never match, and the algorithm will never terminate. To account for this, an iterational limit is typically introduced to stop the algorithm after the specified number of iterations has been done. Then let's go further and compare it with the application or the canonical problem of object classification. Object classification assumes that the classes are known and can be rationally populated. Object classification involves collecting data and objects and assigning them to one of the several categories. So actually, there is a one-to-one relationship between the classes and the entity. So it differs from clustering in that it uses the predefined classification categories, while in clustering, the cluster category depends on the data and the objects themselves. It is also something what I can mention here, that object classification typically doesn't have that sort of dynamic recomputation and that sort of dynamic clustering, which also may lead to moving from one particular data entity to a different cluster. The task of object classification is to predict discrete class labels from the input data and objects after a model has been trained on labeled data. The typical applications of classification include face recognition, image recognition, and medical diagnosis. And the typical mechanisms which are able to conduct object classifications are, for instance, logistic regression, support vector machine, neural networks, random forest, and Gaussian process classifiers. Classification has a rather circular process. The process starts with data collection and then continues with the class specification. Then the characteristics or features are selected. Then the model is selected or generated. And then the classifier is further trained. Then, after doing all this, the classifier is evaluated and it may lead to its termination. However, if the evaluation results negative, then the process may go back to the training or to the model choice or to the feature choice, or even the class specification, because this is a kind of easy solution if you cannot sort the data into classes, try to define new classes. So this is the activity cycle of classification. The next canonical problem is pattern recognition. Pattern recognition is a data analysis method to automatically recognize patterns and regularities in data quickly and accurately. The data can be anything ranging from text through images to sounds or other definable qualities. Pattern recognition mechanisms can be application-specific and general-purpose mechanisms. The latter is represented by neural learning mechanisms. So general purpose mechanisms are actually usable in multiple cases for pattern recognition. They can also recognize unfamiliar objects, recognize shapes and objects from different angles, and identify patterns and objects even if they are partially obscured or truncated. Applications inside the physical system context are, for instance, live stream video processing, speech and fingerprint recognition, aerial photo interpretation. We used it, for instance, in the context of drone generated images stream, optical character recognition in scanned documents such as contacts and photographs, and even in medical imaging and diagnosis. So this concludes the first block. I would like to stop here for a moment and to kindly ask you if you have any comments or questions related to the four types of canonical problems that I discussed so far. Sorry for disturbing.
Any question from any one of you? Any question?
No, sir.
So I don't think if there is any question, you can continue actually.
So I just wanted to know if it was sufficiently understandable, and then I would like to continue with the second block from here onward.
So
And
I hope all of you understood that's what Professor Emre wanted to know from you before he proceeds to the next block. Is it clear to all of you?
sorry, sorry, please repeat it. Kindly repeat it.
No, there's no question. You can continue, I think.
Okay.
Thank you.
I share the screen and then I go further with the second part, which is the functional regression, behavioral generation, and knowledge acquisition problems. So what is this canonical problem, which is typically referred to as functional regression? So obviously, we know about mathematical regression, and we have heard, or you most probably heard about linear regression and these sort of stuff. So functional regression is a computational analysis mechanism that tries to predict continuous quantities from input data. So it is about providing not discrete data, but continuous data which can be used, for instance, for prediction, forecasting, and similar tasks. Functional regression is a version of regression analysis when responses or covariates include functional data. Functional regression models can be of four types depending on whether the responses or covariates are functional or scalar. So this is actually the the being a function or being scalar. This is the in a kind of compositional way provides the four different types. And we can identify a model which is providing scalar responses with functional covariance. Then we can have functional responses with scalar covariance. We can have functional responses with functional covariance. And finally, we can have scalar and or functional responses with functional or scalar covariance. These are obviously, again, depends on what data we need, what sort of modeling problems we have. Functional regression models can be linear, partially linear, or nonlinear. Special cases of functional nonlinear models are, for instance, functional polynomial models, functional single and multiple index models, and functional additive models. The typical application fields for functional regressions are, for instance, market forecasting, where obviously the seeing or looking or projecting into the future is playing the role. Then click rate prediction, internet advertising studies, for instance, using a lot of functional regression cases, and the crowd behavior analysis is also something like it. So that's what I believe a kind of summary of the fundamental terms. And if you are interested in knowing more about functional regression using the key terms indicated here, you can find a lot of information about these on the internet. Then the next one is behavior generation, which is a unique field of interest, and actually it was fueled by the proliferation of the game industry, and in particular by the proliferation of serious games. So a challenge for a game-based cyber-physical system for game-based cyber-physical system developers is the need to create compelling behavior for characters and objects. Perhaps you remember that in that application example, which I presented as a prototype system for enhancing engagement in rehabilitation processes, we definitely used games, and we had to model the patient behavior with games in order to forecast what to do with the games and when the games had to be changed or replaced even. So most mechanisms, computational mechanisms of behavioral generation have either precompiled scripting or finite state approaches. Scripting is a kind of specification of a scenario, and this scenario is precompiled, and activities happen always according to this scenario. But in order to be useful in the stage of development, you have to know what will happen and what sort of behavior can be expected or assumed as direct or alternative behavior. In order to overcome somewhat this limitation by the introduced by the precompiled scripting, the so-called final state approach and many variants of the final state approach was introduced. Both of these approaches are restricted the requirement to anticipate human behavioral state at the design time. So actually, when you design the cyber-physical system application, you have to consider that what sort of behaviors are there and what you have to model. As I mentioned, finite state approaches seems to be more relieving, more permissive, but nevertheless, they also have their own limitations. So it is possible by using finite state approach to have a wider range of behaviors for the different characters playing role, but it is also requiring anticipation of the expected states and transitions between them. If the characters who are acting are, are defined as agents, in that case, their interaction may have consequences on their characters, and this is a kind of freedom which can be included or considered in case of using finite state approach implementation with genuine agent-based technology. Then the concept of runtime plan-based behavior generation was proposed for interactive game environment, and this approach, which is well documented in the literature, was also taken over by cyber-physical system developers. And nowadays, actually, many people are experimenting using plan-based behavioral generation. And by creating behavioral control on demand, a planning-based approach has advantages over the techniques of pre-scripting behavior or even using finite state approaches. Let's shift our attention to the next issue, which is knowledge acquisition. It appears as a canonic problem because actually it is very, very important for all knowledge-based systems, and this problem, namely the knowledge acquisition problem, is known in artificial intelligence research since the late 80s, and many different techniques have been proposed for knowledge acquisition, which is in fact the process of locating, collecting, and refining knowledge for development of knowledge-based systems and smart cyber-physical systems. Four sub-processes are to be taken into consideration at attaining knowledge, which are observation, explanation, prediction, and control. These are different activities, and their essence is as follows. Observation can be a system internal or external and permanent or temporal observation related to the knowledge used of a particular system. Explanation is also a knowledge acquisition form, which means the elaboration of facts of knowledge in a logical manner for a series of events, what the cyber-physical system executes. Then prediction is a process related to cause and effect based on which the results can be predicted. And then obviously the knowledge, what was used for this particular prediction or particular prediction, these are elicited. Then the control is the process in which the results are filtered out by existing control on certain factors. So this is a kind of causality type of evaluation. If you receive these end results, then how they were achieved and what sort of factors were playing role there, and this let's say capturing of the factors that contributes to knowledge acquisition. We have to see that the knowledge sources can be very diverse in the context of knowledge intensive systems, but also smart cyber physical systems. For instance, as I just mentioned, the knowledge may come from the result or the procedure of problem solving. It can be also sensory information, something which appeal to the senses and can explain what the sensing is around. The sources of knowledge can be also, for instance, abductive reasoning, but also taking over statements from some sort of scientific or professional authority, or concentration and meditation, and appeal to experience, what we experience and how we experience it. Then sources of knowledge can be intuition and heuristics also. Inductive reasoning can also provide knowledge. Retrospective reason, what happened in the past and what does it mean now for us. Then deductive reasoning, what can we explain with general theories and what sort of pieces of knowledge they induce. Then the tradition, what has been done as a kind of element of culture or a best practice. And finally, observations and interpretation of the thing. So why the knowledge acquisition problem in itself seems to be very straightforward, in the real life it is a rather wide spectrum, and we need dedicated methods to operate successfully. Although it was not mentioned as a canonical problem, but so frequently occurs with regards to cyber physical system development and also using neural network based solutions, that I would like to elaborate shortly on the problem of dimensionality reduction, because this is one way of making effective our work. Instead of using the initial data, we can substitute them with higher dimensional data, which are nevertheless more or less maintain or contain the same information content as low-level data does. So this is my argumentation why we have to consider dimensionality reduction as one of the complementing canonical problems. Dimensionality reduction is used in applications when raw data have high number of dimensions. Dimensionality reduction approaches map the high dimensional data onto lower dimensions while preserving relevant information. Dimensionality reduction reduces the amount of random variables in a problem by obtaining a set of principal variables. Dimensionality reduction simplifies the modeling of complex problems, eliminates redundancy, reduces possible model overfitting, and thereby including results that do not belong. So I hope this illustrates the crucial role what dimensionality reduction can play. Two elements of the dimensionality reduction focus are feature selection and feature extraction. Feature selection extracts identifies subsets of features from a set of many dimensional data to represent the model by filtering, wrapping, and or embedding. And feature extraction reduces the number of dimensions in a data set in order to model variables and perform component analysis. There are plenty of methods for doing it. So actually, without going into the technical details, you see here a common a common list of dimensionality reduction techniques. And if you say that which one is the best in a particular application, and you pose it as a question to me, I have to say that I don't know. It depends on the objective, it depends on the application phase, and depends on the computational performance indices, what we would expect from this. So that's why the decision is always difficult, and this is why experts are consulting over a longer period of time before they use particular methods of AI in the process of artificial intelligence, in cyber physical system development. There is something what I would like to mention and very aptly exemplified in the Python programming environment, namely the integration, the close integration of the different canonical problem and problem solving approaches. Here is a overview which are actually stolen from the Python help material. So you can see that Python allows you to apply different canonical problem solving approaches in a kind of combined way. For instance, classification, clustering, dimensionality reduction just mentioned, and different regression orientated techniques can also be used from the scikit-learn. Then we got to the end of this particular presentation. Let me again conclude with mentioning a couple of useful literature material for you. The first one is the Kawasa Charles and Mead paper on planning character behavior in interactive storytelling. You remember that I mentioned the problem of scripting or state space representation, and in this particular paper, a lot of additional information is provided about how to model character behaviors in a kind of anticipating way. The next paper, co-authored by the presented authors and many more, is on a systematic review of dynamic multi-object identification and localization. The next paper I suggest you study in your time, if you are interested in that, is actually a somewhat oldish paper, but still very relevant, applying AI clustering to engineering tasks. It's very clear on the basis of AI clustering. Then the next paper is about the big data classification, and it gives a kind of survey of the most popular techniques and tools. And finally, I would like to mention this paper, which is about the use of artificial intelligence for securing industrial-based cyber physical systems. So you will see that many of the techniques, what I mentioned here, the related to, for instance, reasoning and related to learning are applied in this particular paper in a combined way. So this concludes the today's presentation, and let's just me remind you that in the first part of this lecture, we were focusing on the canonical problems of machine learning from a interpretation point of view, and then we looked into the manifestations of the canonical problems of machine learning. And in the first block, I focused on the identification, clustering, and classification, and on as well as on the pattern recognition problem. And in the second block, I briefly dealt with the functional regression, behavior generation, and knowledge acquisition issues. So that was the presentation part for today. Obviously, you will have still work for this afternoon, but also please stay tuned for tomorrow's presentation. And for tomorrow morning, early afternoon for you, obviously, I will give an overview of the knowledge about the brain associative processes, and then something about how the associative reasoning has been used in various types of neural networks. I assume that many of you are strongly dealing with these sort of things. So again, please don't forget that I cannot discuss everything in detail. Anyway, this is mainly for master students who are taking the course, which is about developing smart cyber-physical systems, and these are just additives to that. Thank you so much for your attention so far. I stop sharing and ask the question if you have any comments, reaction on what I have discussed until now.
Sir, excuse me, sir.
Mr. Vasant,
Sir, it was,
please.
yes, sir, it was really a nice session and really understandable, sir. Sir, I have one basic question. So, sir, while applying machine learning technique, we for training a neural network, we give some input data. Sir, in case of the images, in case of images of a particular part, what can be the criteria identifying the features actually? For example, in a particular figure, in particular image, there are certain features on the basis of which we need to label it whether it is of certain class or the different one. So, sir, what can be those feature extraction criteria?
It was
So it may be some shadow color or like that.
It was a very long question, and I have to confess that that I could understand, but not semantically, but based on the sound transfer, only half of it. So you were asking me about the training with data, training a
Yes.
particular machine learning mechanism, and then
The feature extraction criteria, sir, I am asking about.
what
We are, which are,
here?
yes, sir, we are denoting some features that these are the features on the basis of which the network will identify whether the image is category, certain class, will label it, and the different one maybe. So, sir, what can be those criteria actually in the image?
Uh, uh, Still, the sound is broken, unbelievable. So I tried to reconstruct what the question might be. Sorry for this. I don't know what's going on with the sound, with the communication. So you are asking me if you are in the training process, right? And then
Yes, yes,
you want to uh, go into labeling, yes?
yes, correct, sir, correct.
You want to define the features and use them for labeling images, as I understood you correctly. Yes, so images are
Correct, sir, correct. Images, yes, yes.
I just sorry for that, Mr. Vasanta. Can you please write in the very essential?
Yeah, yes, sir, correct, sir. You're going right. Correct, sir.
Sorry for that I so can you please just as bullets write up the questions, the elements of the questions, and then I will respond to each of them. I promise. If you
Yes,
Any other question anyone has? If no question, I'll request you once again, all of you, to kindly switch on your cameras. Vivek, you have to change the angle of your camera because your face is coming horizontal rather than vertical.
yes, sir, sure, sir, sure, sir. Sure, sir. Our side. Yes,
Mandoi, Rahul, Ruchika, Jefferson, kindly switch on your cameras. Rahul, are you there? Ruchika,
Yes, sir, yes, I'm there.
please switch on your cameras. Okay, so everybody smile, please. Just one more and okay. So thank you very much, and we have like we're going to give you break this lecture prior to that, but now you have got break, 20 minutes break. So we'll reassemble at 4:30, and we'll continue with the hands-on sessions which we are doing for last 2 days, so that whatever you are learning, you can get exposed to those things. So see you at 4:30. Please be on time.
please allow me just one comment to Mr. Santa. Either using the chat button, even better if you send in an email the question to me and I promise you to give the answer. I don't know what is going on with the song. There are things which are very clearly here and there are very noisy lines which I don't know what happens with them. Also today, and this is an information for you, Pune, sometimes I heard that certain channels were opened and the noise came up on my side. I sorry, it is not a complaint. This is the reality. Obviously, there are several thousand kilometers in between, and it is understandable. But on the other hand, it also influences the, how to say, the communication between us. I apologize for these technical problems anyway. I nevertheless hope that the message is over there. So, Mr. Vasant, please send me the.
yes, sir. Thank you, sir. I'll email you, sir. I'll ask you the in
Thank you.
detail.
Thank you so much. And then we meet at 2:05 according to my time.
Yes. With
Thank
it,
you so
with it, that
much.
will be a different group. That will not be this group. That will be a different group.
Thank you so
Okay.
much.
Thank you. Thank you.
Bye-bye for now. Bye-bye.
Bye. Be ready for the start of the last session of the day. Am I audible?
Yes, sir. Yes.
Vivek, there's some disturbance from your side. Please check your mic actually if you have, because okay. So it's 4:30 now. So let us begin. So as I have told you at the end of last lecture also, today this session is specifically dedicated to one another tool, which I am sure everybody knows it and everybody has used it for other purpose. That's Python. So we'll talk about Python today, and we'll look for its application in the cyber physical systems. Uh, Basically, what the topic which we are going to cover is, and it will not be lecture actually, it will be like a hands-on session. So if you can access to your computer, if you can do it on your, it's good. Otherwise, you can just see. We'll take help of one of our TAs, Samir Jain. Samir Jain is doing PhD in the Computer Science Department of Institute under Professor Prajita Oja, and he is one of the experts in the use of Python. He is basically working in the domain of image processing, deep learning, blockchain, AI. So he has a very good hand in dealing with these things. So what we are going to cover in today's session, and since it is just 1 hour, we'll talk about Python basics first. Then we'll talk about loops in Python. We'll talk about lists. We'll talk about dictionaries. We'll talk about NumPy arrays. We'll talk about matplot libraries, and we'll talk about pandas. And you may feel that I have listed too many topics, but we'll give an overall exposure. And as I said in the beginning, if you can practice parallelly, good enough. Otherwise, you can, at the end of the day, you can just practice the thing. The video recording is already available with you, and to YouTube, you can see it and just do it. Now, coming back to Python, Python has gained a lot of prominence in last few years and with a lot of applications, particularly for the non-computer science background students, mainly I'd say mechanical electronic students. In fact, just for your knowledge, in our institute, for the first year students, we have changed their programming language for the course Introduction to Programming from C++ to Python for non-CSE students. CSE students still learn in the first IT 101 course Introduction to Programming C++, but non-CSE students, mechanical, electronics, smart manufacturing, even design students, they learn Python. And Python has become one of the most popular programming languages in the world in recent years. So it is being used in everywhere. Like I'm basically belong to the domain of CAD technologies and advanced manufacturing. So whenever we have to do open-ended programming to customize any geometry or any CAM tool, any CAD tool, we do it by Python. So I have also, in part of being professor, I have also learned a lot. But since I don't get that much opportunity to practice, so probably I may be a poor tutor for you for this particular case. So it is being used in everything from machine learning to including building websites, and software testing also. It is used by both developers and non-developers alike, and it has created like everything. Like I think everybody watches Netflix, so Netflix recommendation algorithm, like you watch one particular program, Netflix start recommending you, since you have watched this, why don't you watch this? Not only Netflix, uh, you look at, for example, Disney Hotstar. Like these days, most of us watch IPL matches, so Disney Hotstar will recommend you, why don't you watch 83, or why don't you watch Praveen Thambe, because these are all related to cricket. So these recommendation algorithm of Netflix, that is also being developed on Python. And in fact, even not only that, I think everybody is aware of autonomous cars or self-driving cars. So the software which controls those autonomous or self-driving cars is also written in Python. So Python is basically a general purpose language. And when we say general purpose language, it means that it is designed to be used in the range of application, a wide range of application, which includes data science, software and web development, automation, and getting any stuff being done. The popularity of Python is due to multiple reasons. So the prime reasons by which makes the Python popular is, number one, it is a very simple syntax. And the syntax mimics natural language. So you don't feel complication in writing program. It is easier to learn. It is easier to read, easier to understand. And it is very quick. It is very easy to make quick projects with Python. And it is in fact easier to and faster to maybe augment the capabilities of Python, the Python based projects. Number two, it is versatile. I told you just now, Python can be used for many different tasks, from web development to machine learning. Number three, it is beginners friendly. That means for the entry level coders, it is very convenient. So it's just like, because you know English, the syntax which you write is very much similar to the natural language. Four, and very big advantage, it is open source. That means it is free to use and distribute, even for commercial purposes also. Another advantage of Python is that it is an archive of modules and libraries. So the bundles of code which are available as open source across the web, which are developed by third-party users and developers, and which can be used to expand the capabilities of Python. And then it is also vast and growing. Python is also very active and large community, which contributes to the development of Python. And the best thing, I think, students in my lab will agree with that, because most of my people basically work in if they work in a CAX tool, they work on Abacus, and they're very limited user of Abacus. So if you are stuck with some problem, you don't find many people who have worked on the similar problem who can help you. Although they also do coding with Python or maybe Fortran or C++. But the big advantage of Python is that it is a very large and active community, which basically are responsible for developing of these models and libraries, which I just now told you, which act as resources for other programming tasks also. But the best thing is that because this is a large set of people, so anywhere when you stuck up, you will find someone who has gone through the similar problem, and probably she or he will be good help to guide you or to navigate you towards the problem, which you don't face, which you don't get in many other programming assignments, particularly when we deal with the non-open source or proprietary software, including MATLAB also. Okay, so with this, I'll request Samir to share the screen and the interface and navigate you directly to the journey of Python rather than talking. So he'll show you Python as such and the navigation screen, through which you can take. So over to you, Samir.
Thank you so much, sir. Thank you so much for giving this opportunity. And now I'm having a small presentation so that we'll be moving around this presentation, and we'll be doing something that is we'll do some codes. We'll run some codes on Python. So this is the presentation that I'm going to show you. Yeah. So this is the very first lab of Python, in which we are going to cover some of the introductory things about Python and some of the things that the scientific community needs to needs those tools to do some work on Python. So I'll give an introduction to that. So this very first slide is already that is already discussed by Tandon sir. So here GPL means that Python is a high level programming language under GPL. So it is a general public license language. So everybody can do whatever they want to do using Python. So there is no need to take to give the license fee. And if you are using the Python, so for development purposes, today Python is much popular due to this main thing, that is it is not charging any kind of fee. So yeah. So the second thing that we are going to cover today is input. How do we give input to the suppose we are using a Python platform. So how to give input, how to print whatever we want to, like we want the results to get printed. So what are the loops? How we can make the loops? If else functions, lists, and dictionaries. The main part is this, that in when we are making some application or we are doing some research work, then NumPy arrays are very important. So like images, we are suppose we are reading some image from a directory. So using NumPy arrays, we can store that image. Using matplotlib, the second thing, this using matplotlib, you can print that image. You can see the plots of graphs on all that. So when you are writing a research paper, or you want to visualize the data, so you can use these matplotlib. And then there is a pandas library where you can do some data science kind of thing. So like we have to analyze the data. So pandas, matplotlib, numpy arrays are very important apart from the basic structs that are available inside the Python language. So first thing, since we are going to do some hands-on on this Python language, so you need a compiler for that. So for that environment, Google has provided a Google Collaboratory. So what you can do is open the Gmail. So this is my Gmail. So this is the Gmail account, and here I'm going to my drive. So this is my Google Drive. So I want everybody to do this exercise. So first we are going to this drive, and now I'm creating a new folder. So in my drive, I'm creating a new folder. So the folder that I'm going to create is I have already created, because I have to add some data to that folder. So I have a folder that is GIAN underscore CPS. So this I've already created in my directory. So this is the folder. Okay. So now what you can do is for Python, for doing coding on Python, there are several platforms like Spider is there, Jupyter Notebook is there, but Jupyter Notebook is much more preferred in wide, wide areas. Like if you belong to mechanical, or if you belong to electronics, or there is a person from computer science. So most of the people want that their code should be very much easy to see, easy to run. So Jupyter Notebook is very easy to analyze. So first thing is that from you that I want is you have to create a Jupyter Notebook file. So this is the Jupyter Notebook file. How you can do that is when you have created a new folder. So suppose you have created a new folder in the directory. Suppose you have created a folder, test folder. So this is the folder that you have created in your directory. Get inside this folder, and then you have to, after getting inside this folder, you have to right click on this, just go to more, and here you will find that there is a icon for Google Collaboratory. So there is a link for Google Collaboratory. So here what you want to do is, what is needed from you is that you have to right click on this more, then you may find this option, Google Collaboratory. If it is not there, just go to the mail, and there is this kind of thing. There are much tools that are available in from Google. So in these tools, you have to go to this more from Google Workspace Marketplace, and here there will be a new link that will be opened in a new tab. So you have to search for Google Collaboratory. So Colab, you can type Colab. So since this is already installed in my system, it is saying it is installed. But if it is not used by you earlier, so you can install this Collaboratory. Okay, so it is a tool that is that will be linked with your this Google ID. So not Gmail, I'm saying Google. Okay, so there are much more tools that are available from Google that are linked with your Gmail. So this is what Collaboratory is linked with my Gmail. So I'm going to create a new file. So this is Collaboratory file, and you will see this new notebook. So we used to call it as Jupyter Notebook. So Jupyter Notebook comes uh, from the Anaconda environment. That is Anaconda you can separately install in your computer system. But if you don't want to install anything, you can directly use the Google Collaboratory that will be on the cloud. So we are using this Collaboratory in the cloud. So the cloud that is given by the Google. So this is the very first thing that we are going to do is opening a Collaboratory notebook. So this is a IPyNB. This is Interactive Python Notebook, IPyNB. So I stands for Interactive, PY for Python, and NB is for Notebook. So this is the Jupyter Notebook. So I'm renaming this file as GIAN CPS 22, GIAN CPS 2022. Okay, so this is the name of this file. Now in this environment, you can see that there is a link, there's a button that is for connection. So connection means there is a virtual machine, like there is a another system that is given to you by the Google. So from the cloud, you are getting a system on which this notebook is going to run. So I'll click on this connect. So meanwhile, I'll ask everyone in the chat. So if you are in the Jupyter notebook like this, you can type collab. If you are inside this Collaboratory notebook, you can type in the chat if you are here with me. So you can type in the chat collab. And if you have connected this Collaboratory notebook to this Google Cloud, so you can type connected. Or if you, yeah, thanks. So okay, I'll be waiting for another couple of seconds. So that I'll come to know that if you want this you want me with you, or should I? Yeah. So should I proceed? So please tell me if should I proceed or should I wait?
Please answer to what Sami is asking.
Please proceed, sir. Please proceed.
Okay. Yeah. Thank you. So these are in this Jupyter notebook. These you can see that it is connected. So you are having some RAM. That this RAM is actually you're having 13 GB, near about 13 GB of RAM, and this is the total storage, disk storage that is given to me by the institute. So linked to the triple ID DMG account. So it may vary from user to user. Okay. So these are known as cells. So this is the first cell, that very first cell that you are you are seeing right now. So first thing is that we want to run some programming constructs of Python. So first thing that we are going to use is in in each and every programming language, the first thing is you have to print hello world. So I am writing hello CPS, GIAN CPS participants. Okay, so you have two things. Either you write this thing in the cell and click on this play button, so it will run. Or what you can do is Click on that, then shift enter, press shift and enter. So you need not to press on that button, it will automatically get executed. So this is the first thing that we are going to do is printing something that is written inside this print statement. So second thing is, if you want to take input from the user, so from for taking the input you have to type input. This is the function, input function. Inside input function you have to type, like suppose I'm asking you what is your name, and it is having same thing, like C has like backslash n new for new line. So I'm writing this. Yeah, so what is your name? It is asking you what is your name. So I'm writing this like Samir. Okay. So what is your name? Samir. Okay. So suppose there is some input and you need that that input has to be you want to use that input. So what you can, how you can do is, like, I'm typing name equal to input, what is your name. So whatever I'll give the input, it will be stored inside this name variable. So name is the variable. Okay. So how you can do that? So I'm going to print my name is, and the name that is being given by you. So name. So this plus means concatenation. Concatenation means like you are adding. Suppose you are sticking two things. So that is concatenation. Okay. You're not adding two things. You are just sticking two things. So I'm sticking with this statement. My name is, this will be printed as it is, and the actual value inside the name. So inside the name, the value is Samir. So how I will do that? So first I will run this cell. Now I'm writing Samir Jain. Okay, I'll press enter. Then now name contains Samir Jain. This name variable contains Samir Jain. How you will come to know? So when you have, you can add a new cell by using this button plus code. So this is a new cell. Okay. Now I want to see what is inside the name. So I'll copy this, then paste this, and then run this cell. And now I can see that name contains Samir Jain. Now I'll run this statement. So output will be my name is Samir Jain. Okay. So this is what how you can take the values from the user and then you can print these values. So this is very basic thing that you can see inside the Python. Now, suppose you want to loop into something, like we want to print from numbers from 1 to 100. So we can use for loop. So for I in, so suppose I is the iterator. Okay. So suppose there is a and there is a length, there is a list of numbers. Okay. So 1 to 100. Now I want to iterate on them, or I want to print the numbers from 1 to 100. So how I will do that? So either I can do print 1, print 2, print 3, print 4, like that. So it needs 100 times. Suppose if you don't know how many times you have to run this statement, then you can use a for loop. So for loop can be used. So for I in range, you have to type like this. For I in range. For I in range, then you have to give the range like 0 to 100. And then press, okay, 0 comma 100, sorry. Okay, now you have to like print I. So if you'll print I, so the numbers will be printed from 0 to 100. Okay, you can see over here that I will print from 0 to 100. But here you can see the range is from 0 to 100, but it will take less than 100, one less than 100, that is 99. So here it is 99. Okay, now here you can, what you can do, suppose I want to iterate I such that it should hop with two values, like it should skip two values. So how you can do that is you can press you can give a value 2 over here. So 0 comma 100 2. So it will skip, like it will increment with 2. So first it will take 0, then skip 1, then 2, then skip 3, then 4, and all that. So You can see over here. So 0, 2, 4, 6. So you want to print. So this is the program for printing the even numbers. Okay. So you have printed the even numbers. If you want to print the odd numbers, you can skip with 3 or whatever logic you can want to make it. So we'll start from suppose 1 and then we will skip with 2. Okay. So let us see. So it is the program for even numbers, sorry, odd numbers. So this is how you can use this for loop. And this is what a looping kind of thing is done inside the, Python. Another thing is that um, um, there's one thing that is known as list in the Python lists. So here, if you are, I'm given hash over here. Okay, so this hash suggests that and this is commented. This line is commented. Commented means that this line will not execute. Okay, so this is how comments are added. Like suppose I want to write it like this is the loop for odd numbers. Okay, so I'm writing like this. So this is a loop for odd numbers. So it will not execute if you have added hash over here. So hash states that this is the comment. Okay, it will not execute. So dummy kind of thing. So lists. What are lists? So lists are something where you can store anything inside that list. Like suppose X is a list. So X equal to like 1, 3, 4, 7. So this is the list. Okay. Now, yeah. So this is the list. Now I can use this for loop for printing the values of list. How I can do that is for I in range length, or for I in, you can type directly for I in X and print I. So whatever values will be inside X, that will get printed. So 1, 2, 4, 7 is printed. Okay. Another thing you can do that like this for I in range length of that list X. So what is length of X? Suppose I want to see. So I can do this by printing length of X. So length of X is 4. There are 4 elements in this list. Okay. So for I in range length X, and then I can print this list is X and the index value will be I. So I will have range 0 to 4. So x0 will be 1, x1 will be 2, x3 will be 4, and x4 will be 7. So this is how it will work. Yeah. So 1, 2, 4, 7 again same thing. Okay. So this is how you can do. You can make use of this for loop to print the values inside the list. Okay. Now there comes a very important thing, that is dictionary in the you know in Python. So dictionary, what is dictionary actually? So dictionary is it is similar to associative memories. So suppose you have learnt about hashing, some hashing kind of thing. So like in cryptography there is hashing. So when you have a key and through that key you want to access some value, so key value pair is there. So yes, so in this way we can have dictionary inside the Python. So suppose I have a Python dictionary that is for participants. So suppose there's a dictionary. So you need not in the Python, you need not like declare anything like this is list. It will automatically consider it as a list. Okay. Suppose I am giving, so it according to the syntax, it will automatically take it like whether it is a dictionary or a list or a variable. So you need not give anything like data type is there, just like in C or C++, where in Java also you have to type the data type. You have to give this, you have to specify the data type. So it is not needed in Python. So if you want to like declare an empty list, so how you can do that is you can name the list like Z. Z is a list and it is an empty list. Z equals to null. So it is a list. Z is a list which is empty. you can add an element to this list like z.append, z.append 1. Let us see if it works or not. Yeah, so z. Now z has length 1. It is having value 1. Now I am writing z.append 2. So what will happen? Z will have two elements, 1 and 2. So if I'll put this statement inside a for loop, if you are doing something in the programming, like you are adding some image, you are reading some images from a folder, and you want to save those images in a list, then you can do this one. You can use this kind of thing. So z.append that kind of that image, and then that will be added to this list. So z1, that is having 1 and 2. So if you will keep on appending something, then the list will have the length of the list increases for each value. It will get appended. Okay. Now the second thing is dictionary. So how dictionaries work? Okay. So I am having a dictionary like participants. Participants is a dictionary, and how it will going to see that whether it is a dictionary. So here you can see these are parentheses. Here there were square brackets. So this is a list and this is a dictionary. So how you are declaring, like, so suppose I'm writing triple IT DMJ. So there are total how many participants? 200 from triple IT DMJ. And suppose I'm using another, like, from mainnet. So from mainnet, there are how many participants? 100. Okay. So this is a dictionary. Okay. When I will write participants, and then I'll add this triple IT TMJ. Okay. Okay. PAN. Okay. So sorry. So when I'll write participants triple IT DMG, so it will give you the value. Okay. So whether it is in the third place or fourth place, whatever you will write, like if I'm writing IITK and it is suppose 300, 3000. So when I'll write IITK, so it will give you 3000. So whatever this is key. So whatever key is is passed to through this dictionary to this dictionary, then it will give you the result like this. Now suppose I want to add these things like 200 plus 100 plus 3000. Okay, so it is 3300. So what I'll do, I'll take values equal to party, and then it will see what it does. Actually, whenever we are using these kind of platforms, it will automatically give you the suggestion like PAR. I'll type PAR, and then it will give you, yeah, participants. So yeah, participants, and then in the participants I want to add the values. So we'll take the values of participants. So values, participants dot values. Now values has many things, like, so how many values are there? 200, 100 and 300. Okay, so I'll see what are the values. So it has 200, 100 and 3000. Okay, now I want to I want to find the sum of that. So total equal to sum, and then I'll type values and then print total. So the values are printed. Okay, the sum is printed. So 200, 100 and 3000 is 3300. In this way, you can have dictionaries. Okay, so dictionaries, where the dictionaries are used actually. So as I've told you, when you are doing some hashing, when you are doing some cryptography kind of thing, then these dictionaries are going to be used inside whatever you are going to implement. Now, now the main part of this tutorial is the numpy arrays. So suppose I'm creating a tutorial, so I can add a text, this, and then I can tell you that, yeah, so numpy arrays. So it is like this. This cell is, you cannot run this cell. It is just for displaying something, some information. If you put another hash over this, so yeah. So if you want to, like, if you want to make it bigger, so number of hashes, if you will add, it will become more bigger. Okay, like you can see over here. If you remove one hash, then it will be a smaller one. Okay, so this will be like this. So this is, text. This is for text only. Now numpy arrays. So what are numpy arrays? So in the numpy arrays, there is this is for only scientific computing. Like if you want to store something in an array, you want to directly apply some of the operations, like some rotation you want to apply. You want to find the average, variance. You want to find the maximum. So using NumPy, you can do this thing. So NumPy is a package for scientific computing. Okay. So how you can do that? So suppose I'm going to create an array of a NumPy array. So how I'll do that? So first I have to import this library. So import NumPy as NP. Okay. So here you can see that for these operations, like for list, creating a list, for printing something, for finding the length of a list, anything, we need not import anything from Python because it is directly available. But these are some basic things like that should be there when you are doing some Python programming. But NumPy is not, available every time. So you have to import the NumPy that comes along with Python packages, and sometimes if it does not come, you have to install the NumPy library. Okay. So in the Jupyter notebook that is given by Google Collaboratory, the NumPy package is already there. When you are installing Jupyter notebook using Anaconda, NumPy is already there. So you need not install it separately. But in certain cases, when you are having a very small memory, or you are doing something where only Python is installed, so you need to install NumPy separately. Okay. So import NumPy as NP. Now NumPy, we will refer NumPy as NP. So wherever we'll write NP, it will refer to NumPy. Okay. Now, so first thing is, suppose I am creating a NumPy array. So let A equals to NP dot array. So I am telling that, yeah, I'm going to create an do
Lost
some
you.
operation like, yeah.
There was some disturbance in your voice actually in between. Can you repeat just what you said just now?
Yeah. Okay, sir. So this is a NumPy array. Here I am creating a NumPy array using NP. So this is the library. So NP dot array, and this array contains 5 values: 1, 2, 3, 4, 5. Sir, is it clear right now?
Yeah, it's perfectly all right now.
Yeah. Thank you, sir. So this is an array. So A is a NumPy array. So this is array of 5 elements: 1, 2, 3, 4, 5. Now I can do something like NP dot. When I'll type this NP dot, it will show you that what you want to see. So I'm typing NP dot S, and then it will suggest that, yeah, I can do sum, SUM. Okay, NP dot sum. So NP dot sum, and then I'll pass A. So it is 15. So you can directly apply some of the operation like NP dot average. This is average. Okay. And then, sorry. So it will find the average of these elements. So it is 3. Okay. NP dot mean. So these are the things like NP dot max. So likewise, you can do certain things like using if this a particular array is numpy array, or suppose there is some array like if you want to create a array of zeros or ones, so you can also do that. How? Suppose I want to create an array of ones, so I am typing ones equal to np dot ones. So it will give you an array of ones like np dot ones, and I'm giving the size of that array like 2 comma 3, okay, comma d type equals to uint 8, okay. So again, data type I can give like what kind of array I want to get created, like you want to have an array of integers, you want to have an array of floating point. So in this way you can create. So it is this ones array is of size 2 comma 3. So there are 2 rows and 3 columns, okay. Suppose I'm creating an array. So I'm typing 2D. So I want to 2D array. I want to create a numpy 2D array. So np dot array, and then I'm creating that array like this. So this is a 2D array. 1, 2, 3, 4, 5, 6. Okay. So this is a 2D array. Now, what is a good thing with NumPy? You can find these like np dot sum average along the axis also. Like suppose np dot sum, and then I'm passing array as 2D array 2. So this 2D array and comma axis equal to 0. So axis equal to 0, it means that you are having along these columns like, so 1 plus 4 is 5, so it is giving you 5. 2 plus 5 is 7, and 3 plus 6 is 9. So along these axes it has given you the addition. Suppose I want to find the row wise sum, so I'll give the axis. So row wise sum is, first row sum is 6, so 1 plus 2 plus 3 is 6, and 4 plus 5 plus 6 is 15. So in this way you can have according to the axis of that array, you can find these particular values, like what should be the sum of all rows, what should be the sum of all columns, like that. So in this way you can also find the mean, max, average, and all that. So for scientific purposes we are going to use this numpy arrays. And there is one more thing, like suppose I want to find the unique values inside a particular array. So suppose there are values like 1, 2, 2, and this is 6, okay. So 1, 2, 2, 4, 6, 6. So how many unique values are there? There are 1 is unique, 2 and 4 and 6. 1, 2, 4 and 6 are unique. So I can type np dot unique 2D array, okay. So it will give me suggestion, yeah. So it will give you these values. Okay, I have to, yeah. So yeah, so it will give you 1, 2, 4, 6. Okay, so how many unique values are there? So suppose I wanted to find like there is an image data, and I was just wanted to see the unique pixel values. What are the pixel values that are here in my this thing? So I can use this. Now suppose I just wanted to convert this numpy array like this is 2 cross 3 array, 2 rows and 3 columns. So np dot reshape is also there. So np dot reshape. So reshape is also there. Okay. So you can use this reshape like a, and I am writing 3 comma 2. So okay. So I have given a, sorry, it is 2D array. Okay. So one more thing that if there this is a big problem with the people who are not from coding background. So you have to learn from like these errors that are coming to your that are coming. So don't get fed up with these errors. Try to learn with these errors. So it is these in this in Python the errors are very very simple. You can read it and you can correct them very clearly. Means there is no problem in writing that. So in correcting those errors, okay, so you can do like easy rectification is there. So now earlier the array was of 2 cross 3 size, now it is of 3 cross 2 size. So you have reshaped, like suppose you want to do some transpose operation. So you can type this np dot transpose this. So that is what actually the numpy has. So there are ample operations that are used in the scientific works, and these operations are already given inside the numpy library. So you need not to reinvent the wheel. It is already there inside the numpy library. So there are many operations. You can explore this numpy array library, and then you can proceed on with your work. Now the next thing is, suppose I want to let us take one image. Okay, so where is my, let us see where I am right now. So present working directly, pwd says I am inside the content. Okay, so here in collaboratory, you can, what you can do is you can read the data from the drive, so suppose this is the drive. I can read the data. So suppose I am taking an image, so pictures. So suppose there is a picture, like yeah, this is the picture. So I'm placing this picture inside this folder. Okay, so where I am, the GIAN CPS test folder. Okay, now in this collaboratory notebook where I am right now, inside the content, so I need to reach to the drive first, and then I have to get inside the CPS folder and then into the test folder. How can I can do that? So there are 4 options in this beside this notebook. Okay, so you can see there are 4 options. So first option is upload to session storage. Okay, second option is refresh. Third one is mount drive. So you have to go to this mount drive option. I'm clicking on this thing. It is asking permit this notebook to access your Google Drive files. Now I'm permitting this. It is saying mounting Google Drive. It may take time. So mounting means now this virtual machine that you have got here, where you have got some RAM and disk, now you can access the external drive. External drive is, that is Google Drive. Okay. Now, so here you can see that there is a drive option. Now I can get inside this. I'll get inside this this folder directory, and there are 2 more directories: my drive, shared drives. Okay, so I'm inside my drive. So I want to go inside my drive, and then I have to search for the CPS. So what is that folder? That folder I need is GIAN CPS. So I'll get inside this. I'll search for GIAN CPS. Yes, this is GIAN CPS. So I've got this GIAN CPS, and inside that test folder. So inside this test folder, I have this Python notebook that is stored, and there is one image file that is untitled.png. So I can do this thing, like I can rename this file. So I am writing this image.png. Okay, so the name of file is image.png. Now I can refresh. Okay, so the name is image.png. Okay, now I'll get in how I can go to this test folder. So you just beside that test folder, you have to click on this options, then copy path. Now type cd and copy that path. Run this. So you are inside the test folder. When you will type ls, list all the files. So you'll find that there are 2 things: GIAN CPS 2022 INB file, this file, and then image file. Now I want to read this image and print that image in this particular this notebook. So how I will do that? So for reading the image, you can use matplotlib. So I am typing import matplotlib.pyplot as plt. So matplotlib is the package where there is a pyplot class, and plt is the object of that pyplot class. Okay. Now I'm going to read an image. So plt.imread. So this is what plt.imread function I'm calling, and what you want to read is image.png. So I'll type this. I'll give this thing like I want to read this image.png. Now it is giving you the image value. So image in the form of values. So I'll type um, image dot shape. So what is the shape of this image? So image, okay. So I'm typing img equals to, sorry. So I have stored that image in a variable, and then I'm typing img dot shape. So this file is of size 806 comma 1056 comma 3. It means that it has 806 rows, 1056 commas, and three channels. Okay. So when I'll get inside this, suppose I'm going to the properties details, it is giving you 1056 comma cross 806, and 24-bit depth means 8 into 3, divide by it by 8, then you'll get 3. So there are three channels RGB. This is an RGB image. Okay. Now suppose I want to print that image. So plt.imshow img. So that image will be printed over here. Yeah. So that image is now printed. So this is the image. Okay. Now I wanted to see the red channel of this image. So RGB values are there. So how I can do that? So this image has three channels. So 0, 1, and 2, three channels. So first channel will be img, all rows, all columns, and first channel is 0. So plt.imshow, this is the red channel. Okay. So this is how, or you can type like CMap. Color map is also there's one more option for color maps. CMap equals to gray. So in gray mode, you can see this image. Yeah. So this is red channel value. If you want to see the green channel value, so one thing is you have to change is 1. You have to change it with 1. So this is red channel and this is green channel. So you can see the difference, that what information green channel stores, what information red channel stores, and then blue. So blue channel. So for blue channel, you have to give 2 as the channel value. So 0, 1, 2, there are three channels. So this is a blue channel. So here you can see there are different images. So for analysis of data, like analysis of images, I'm working on medical imaging. So I just wanted to, always we need to see if we are having some data sets. So we always analyze that what kind of images and are there and what kind of information is present inside that image. So in this way, we used to analyze the images. Okay, so this is what matplotlib does. And again, suppose I want to plot some plot some cosine and sine like in this by using matplotlib. So how you can do that? So the very simple formula will do like this. So suppose x equals to suppose let us arrange. So np.arrange is like sorting sort of thing. So 0 comma I'll take pi value. So 3 strict np dot pi. So np dot pi is actually 3.14. So numpy also gives you some constants. So np dot pi. So this is 3.14. Okay. And then with 0.1. So it will arrange these values with 0.1. Okay. So Okay, orange is, it is not green. Oh, sorry. Okay, so there are some certain x values. Now I suppose y sign equals to np dot sign. So sign values, it will form a sinusoidal wave on these x values. So y sign is like this. Now y cos equals to np dot cos x. Okay. Now suppose on these x values I want to see the sign values. Okay, I want to plot these. So plt dot, so plt is for matplotlib and p is for numpy values we are taking. So plt dot plot, for x-axis we are taking x values, for y-axis we are taking y sign, comma, oh no. So let us see. Okay, now this is the sign value. Now we want to see x comma y cos. Okay, now suppose we want to plot them both. So we'll take this in a single, and then we'll plt dot show. So there is one session that is being created inside this cell, and it will give you both the waves. Okay, so in this way you can plot the bars, you can plot as many as possible, like whatever tools, other tools like MATLAB gives you, you can do it Python also. So these are the things that you can do using Matplotlib, NumPy. These are very important. So without these, you can do, but it will not be easy for you to do programming. So these are very important. Now we'll come upon the that is pandas data frame. So here we'll start pandas. I've given you just introduction about all these things, so you can find like whatever is beneficial for you. You can explore that library. So suppose I want to do some statistical analysis. You're from some kind of background, like if you are from mechanical background and you have seen that there is a time series data of electricity distribution, or there is a time series data of something like power failures. So how you can analyze that? So you can use pandas data frame. Okay. Now I'm giving you a simple 2-line code, and then I will do something on a CSV file. So suppose s equals to, first we will import pandas. Okay, so import pandas as pd. So now pd will refer to pandas. Okay, so suppose s equals to pd dot series. So it will create a series. So pd is different from numpy. So this is pandas, that was numpy. Now I'm going to create a series. So A, B, C. This is a very basic example. Everywhere it is given, so you'll find it easy. So this is one function, as dot describe. This is very good function that is given by the pandas. So you can analyze the data. So here is the analysis. That count is 4. So how many values are there inside this pandas data frame? So there are 4 values. Unique are 4. All of them are unique. Top is A. Frequency is 1. Okay, and D type is object. Suppose there is a series where we are having numbers. Okay, so I'm giving 1, 2, 3, 4, 5, 6. Now I will describe. So I need not specify that what kind of data is. So you can see that for both the things, describe is being called, but for this, describe is another thing. For this, describe will show you another thing. Like for this, describe will show you what is the count, what is mean, standard deviation, minimum, 25%, 50% data, 75% data, max is what. So this is what you can get the analysis of data. in a single, in a single click. You can get these things. So as dot describe is a very powerful thing that is given by pandas. Now suppose you want to read the CSV. Suppose the data is inside the CSV file. So how you can do this? It will take hardly 2 minutes. So first what we'll do, yeah. So I have a CSV file. I want to, I'll take it inside the test folder. This is the CSV file. So this CSV file contains 4 columns. No, it contains 6 columns. Okay, ID, sepal length, width, petal width, and species. So it is iris data set that contains how many samples? So there are 150 samples. Okay, 150 samples, and first row says about what is the value, what is the value, what defines this value. So it is sepal length, sepal width, petal length, and petal width, and this is the class species, like what flower is this. Now I just wanted to read this CSV file. So how I can do that? So I'm getting inside this. So I'm seeing whether this file is visible or not. Yes, rs.csv is visible. So df equals to data frame equals to pd dot read csv. So and then I'll pass iris dot csv. Now this data frame has all the things that are inside this thing. So when I'll print df.
Samir,
Yes, sir.
Intervention. Please try to wind up because we have another meeting actually.
Yes, sir. We are in at the last few lines of the code. Yeah, in this session. Yeah, yes, sir. So this data frame defines. This data frame has all these things that was inside the CSV file. Okay. Suppose I want to see only the IDs or ID with petal length. So I'll type. Suppose new df equals to. I'll take df and this ID and then petal. Okay, key error ID. Okay. It's not callable. Okay. I'm not getting. Yeah. So it is taking only one thing. So new df, new underscore df will give you all the IDs. So in this way, you are having like now you can convert this data frame to a NumPy array, and then you can do certain kind of operations. So you have taken data from CSV file. So you have the data is inside from CSV file to a data frame, and now this data frame can take the values from this data frame. We can take the values to a NumPy array, and then we can perform all the operations whatever you want. So this is all from my side to show you how what are the things that are inside Python for scientific purposes or what for data analytics and whatever wherever it is needed you can use. So it is all from my side, sir. Thank you.
So anybody has any question? Please quickly you can ask some question because we have another meeting in a couple of minutes. Any question? So if no question, one last time you can switch on your cameras for the day. All of you please switch on your cameras. Prashant Sharma, can you switch on your camera? Prashant? So, ready? Okay, so everybody, smile, please. Thank you. So I'm closing for the day and will reassemble tomorrow at our time 2 p.m. Okay. And please remember, those who are not aware, those not present at the time of the first lecture, the mandatory requirement of having a 1 hour quiz examination, we'll do it on Friday, 4:30 p.m. It will be very brief and based upon whatever knowledge you have here in this class. You have to do it within 1 hour and return it back to us by